Good afternoon. I'm Chris Wilson. I'm one of the web standards tech leads at Google for Chrome. I'm here to talk about specifications, standards, what the difference is, why we care. This is going to be a little bit lighter weight, which is good because I'm sure you're all getting really tired and ready to knock off for the day. I wanted to start with why we even care about building web standards. Like at this point, Chromium has a very dominant market share. We could just build features. We could ship them, particularly way out ahead on the implementation curve. Like, why do we care? Why is it still important? And the short version is really that in the Chromium project, our goal is responsibly moving the web platform forward. The web's a broad open platform. We have a responsibility to not fragment it. We have a responsibility not to destroy its ubiquity in the world. And this is the hard part. This is the balance, is we also think it should move forward. And those two goals kind of play against each other a little bit. But we do believe the web needs new features and new capabilities. It shouldn't be static. It should grow. It should extend to match what users need over time. So our ultimate goal is not just to make our own web platform implementation great, though. It's actually to move the entire web forward, to move everybody's implementations forward. So all the users, all the developers, all the web properties end up benefiting. And I want to call out that the web is really unique because it is this shared platform. There are many devices, many operating systems, vendors, engines, everything, and they all. This leads to a vastly larger market. And this happens because of this interoperability, because of web standards. You don't need to get your tools, your browsers, your engines, servers, whatever, all from the same vendor. And when I came to Google, by the way, nearly 13 years ago, from the Microsoft Internet Explorer team, it was because, unlike Microsoft at the time, Google's business was totally built on the web. Like, stewardship of the web was critical for Google. It still is critical for Google. It's critical for a lot of you. I know this is important to pretty much everyone in Chromium. So we have to take this responsibility seriously. Now, it's also important to note, though, that this multi-stakeholder platform means developing for the web, or developing the web platform, I should say, is really different from traditional project management. You don't get to just build a feature, design a feature, ship it, and call it a day. Doing web standards work really means you have to move mountains that don't belong to you. And it also means, though, that you get to impact this ecosystem that's radically bigger than any single company, even if your company is Google. Like, this is why I've done this for so incredibly long. Like, I've been working on the web platform just over 3 decades because it's so impactful, because it's bigger than anyone that I work for or myself. Chrome, by the way, is my 4th browser that I've worked on. 2 of the previous ones at one point in their history had like radically dominated market share. 2 of them. Neither one of them functionally exists anymore in the market. So like, one of the important things is their legacy lives on, and the web will outlast even Chrome. I know that sounds kind of heretical, but it probably will. Like, Chrome won't be necessarily around forever, but the web will continue even past that. So to dig into like how this is different, you really have to look at the difference between a specification and a standard. And the key here is that one entity, no matter who it is, really doesn't get to directly control what the standard says. We have to work together across a whole bunch of different stakeholders. Now, keep in mind, as I think was stated earlier today, we can and will ship features in Chromium that don't have support from other browser vendors or other implementations. That consensus isn't a shipping requirement. Like, that's different. That's a specification. You should have a specification. You should have built your feature really well. There should be multiple stakeholders, but that doesn't necessarily mean you have an open interoperable web standard, full consensus from all the vendors that this is the right way to do things. So the difference, though, is you can't really consider your feature part of the web platform, like a web platform standard, until it's been broadly accepted, until you have that interoperability. So this is a really important distinction for us across all of Chromium, because we do sometimes ship those incubations. We have to be cautious about how we message them and whether we say this is part of the platform on Chromium, or if we say this is a full interoperable web standard, capital S. Again, don't let this prevent you from trying to move the web forward, though. Now, if you think of this, a specification is a really good definition of a feature. It defines a feature, it defines a solution to a problem, but a standard specification is that plus consensus. The point of having a standard is to create interoperability, and getting consensus gives you that interoperability. A spec defines how a feature should work. A web standard defines how the feature does work in practice across the web. Now, to talk about how this actually happens in practice, the W3C, which is primarily the place that we push a lot of things, there are two different kinds of groups. There's community groups and working groups. Community groups are great for incubating features. You don't need to work in consensus. You can actually start something and not have it all right up front. You don't have to have everybody agree. You can have competing incubations even, and that's fine. A working group, on the other hand, it's much harder to get a working group going or to get approval for a working group to take on a specification. And they have to operate by consensus. Like, broadly, people have to agree. Engines have to agree. Multiple stakeholders have to agree. That way they can represent the consensus of the web standards community. And in practice, we use these two different types of groups to take features from kind of inception all the way through to interoperability. Like, we incubate first in community groups, we build momentum, we explore solutions, we bake a design, we generally prototype it, frequently ship it, we get broad buy-in, and then we try to move to a working group, ensure broad consensus, finish off all the details, collect intellectual property commitments. I don't really talk about that a ton here, but it is an important feature of this progression into working groups, and hopefully gain interoperable implementations as well. I did want to mention, for context, one community group in particular we use a lot because you may have heard of it, the YCG, the Web Platform Incubation Community Group. I want to be clear, this is just one place to incubate things. You don't have to use the YCG. Like, this is a clearinghouse. It's easy to get joined. We have loads of people already there. There's like 117 current incubations, I think. But this isn't the only place to do stuff. Like, you can easily create a new community group, use a different community group. We frequently have actual communities of people focused on a topic. So, for example, we have a community of AR and VR people in the Immersive Web community group. That community is valuable. Like, it's a set of people who know what they're talking about in that space, and we can incubate features there and then pass them into a working group. So don't feel like you have to use the YCG. It's kind of a default or a backstop. And again, I do want to point out that even when we do ship features, before getting them as a full standard out of a working group, et cetera, which is frequent, when we don't have those vendors on board, we still have a responsibility. Like, we still maintain this feature. Like, it's still our responsibility to try to build consensus, to get people on the same page, to create a standard, not just kind of sit there and wait and hope eventually somebody picks up the right thing. Sometimes they do. Other vendors will eventually perhaps realize, hey, this was a good idea. Firefox did finally ship WebMIDI, so I get to check WebMIDI interoperable standard off my career to-do list. But we have a responsibility in the interim. Those are Chromium features, not web standards. So I want to shift gears a little bit and talk about what goes into a spec and how specs should be structured, because they're not just like feature requirements docs. I am borrowing very heavily from this talk that Dominic Denicola has given before in previous BlinkOns and other places about how to read, write, and think about specs. So if anything is useful, it's probably from him. If anything is wrong, it's probably from me. But Dominic asked the question of why we care about specs specifically. And he came up with a bunch of the same answers that I've just sort of covered. To enable interoperability by defining the features, doing that openly, encouraging multiple stakeholders, turning a feature into an open standards ecosystem. And he did point out you can get some of those benefits without doing this. Like you can open source code and then just reverse engineer it. That's been done before. You can just have explainers and not have full specifications. But if you really want to define a feature well enough to be interoperably implemented, you need to have a full spec. Like it's a requirement. He described them in a super interesting way that I wanted to highlight. He framed a specification as a program written in a peculiar dialect of English that's compiled for different environments by browser engineers. And I thought this was a fascinating way to think about what a spec, eventually a standard, really should be. Like the web platform definition, the standard, the spec, they have multiple compile targets, right? The different browser engines or implementations or whatever. So we're writing code that has to be agnostic to those compile targets. It's a big part of why we write the specs instead of just writing a reference implementation of the feature. Like specs are the high-level language. Each browser's team of compilers has to figure out how to map that to their underlying architecture. And this also means there are a lot of other coding concepts that apply to specs. Like specs are frequently modularized. They're definitely layered. They may have, like you may have to go through and refactor your specification, improve your specification health, just like code. Like all these concepts actually apply across specs as well as code. Now, when you think about how to internalize what goes into a spec, like what this is sort of how to read and write specs because it's how they're structured more than anything. The WhatWG has some interesting advice on how to read a spec. Basically says, read the entire HTML spec, cover to cover, multiple times, read it backwards at least once, then pick random sections and make sure to follow all the cross-references. Once you have gone through the several lifetimes it would take to do that, I guess you're done. But not really. Like most of us here are engineers or have an engineering background. Draw the analogy between the spec text and code, because it really is it's a code definition that you can run through and head towards a compile target. That spec text should be identifiable. Some parts of it are comments. Some of it are helper functions. Some of it are data structures. Some of it are actual like line code instructions. And you need to recognize the differences inside specs because there are different types of statements in specifications. There's three main types in most specs: normative things, definitions, and informative things. And normative things are really the parts that matter most. This is the actual code. This is the instructions, the set of instructions that get run. These need to be tested. You need to make sure that they're tested. It uses language like must, should, may, sometimes implicitly, but frequently explicitly says, this is what you must do. Definitions, on the other hand, definitions is a little bit fuzzy, but it's really, definitions are sort of the helper concepts. It's sort of like data structures or macros was probably the best one that I thought of, because they help you structure how you do things, but they're probably not tested in the actual behavior. So they're helpful and informative in understanding how the spec works. To go even further, informative statements are really like comments. There's loads of these in most specifications. They're notes to implementers, they're notes to web developers, they're warnings, they're additional information to help you understand how things work. But here's the key thing: they are not normative. You could strip them out and still have a spec that should stand on its own, that should work, that should be compilable. And because it's really important to recognize them, they are usually called out typographically, like you can see them inside the specification. They're super helpful, but you can recognize them because they're called out as notes or non-normative instructions to people. So when you go to write a spec, you need to structure it the same way. You want to make it easy to read, just like you want to make your code easy to read. Follow the best coding practices. Be consistent with what's already there. Like, you don't start a spec that totally stands on its own most of the time. Go read how the HTML spec or parts of CSS do the same sorts of things and try to fit in with that. Be clear about what types of statements you're making. Write good helper definitions. Add informative descriptions. Put comments everywhere. I've obsessively commented my code in the past. There are tons of resources to help you do that. I'm going to reference a few of them, but I obviously am not going to brain dump everything that's in them. There's the WhatWG's infrastructure document. This gives you a lot of standards conventions, data types, data structures, helper functions, loads of things you should know about. There is also the tags design principles document. This is a lot of guidance. I've been pushing lately to try to get this better maintained over time, but this is kind of the style guide that is really good to read. Unfortunately, it is also actively maintained, so read it frequently, but it gives a lot of design principles for the web, a lot of API design advice, tips for IDL, tips on how powerful APIs should work or be thought of, things like that. There are loads of other resources, how to use promises, various other pieces, all the way down to the quick start guide to writing specs with Bike Shed. I mean, Bike Shed stands on its own, of course, but loads of references. And I want to come back to one concept that I said before: what the difference between a spec and a standard is. What makes a spec into a standard is writing these really, really good definitions that are good enough where you can actually get interoperability. Because if you haven't done a good enough job, it's really hard to build an interoperable implementation. Incidentally, because I didn't say this before, you shouldn't feel like a failure as an engineer if you do all this hard work, you write a great specification, you build a great feature, it works great, but it doesn't immediately become a standard. Again, I would have felt like a failure the last 10 years for WebMIDI not becoming interoperable. Standards move slowly. Interoperability takes a ton of time. It's not under your control. And because they move slowly, because people have different backgrounds, different takes on things, they're also frequently contentious, and a lot of the discussions can get a little heated. And I want to kind of wrap up this talk by talking about something I gave an entire talk about at the last BlinkOn, which is that in the Chromium project, we really believe that standards work should be psychologically safe, should be inclusive, productive, welcoming. This doesn't always happen, obviously, but we should be respectful of diverse perspectives and have professional behavior. Fundamentally, we should focus on having constructive conversations, even when we disagree. Now, a couple years ago, Chris Harrelson and I started this effort to try to support this aspirational idea of making standards venues safe, inclusive, and welcoming, as well as productive. I don't really want to dive into the entire detail of this. You can look at last year's talk if you really want to, or look at this document. But fundamentally, we're not trying to replace codes of conduct, because pretty much every standards venue has a code of conduct. We're setting the expectation that the spirit of those should really be honored and followed. Participants should follow some simple golden rules, like be respectful. recognize the validity of other people having different points of view, take actions that are constructive, fundamentally. Now, I raise this, this is kind of like, I want to characterize this for people who work for Google and people who don't work for Google. And the reason why I separate those is one of them, I have some ability to tell you what to do. One of them I don't really, like I can encourage you. But Chrome engineers, like you're expected to adhere to this. Like you're expected to try to have productive conversations, be respectful, be welcoming, focus on being productive. But there's another thing there too, which is you should not have to be abused just because you work for Google. Like I've worked for several large companies. I know what it's like when you go out in a broader space. Not everyone is welcoming, and expect there to be disagreements. But if you feel like this is not cool, like somebody keeps implying you're an idiot or saying you're participating in bad faith or something like that, get some help. Like that's what we're here for. If you don't work for Google, I mean, it would be great if you did that too, but we expect you to ask us to help if you feel like our team members are falling down on this. Like we should all work together on this. If someone doesn't feel like we're participating in good faith, please raise that to our attention. Like we actually want to solve that problem. And how to do that? I would ask and encourage you to participate with people in the room. Like if you feel somebody is not being respectful, say so. I mean, that's the first step. But if you need more help than that, internally or externally, we have a web standards ombuds list. This is a small set of people. It's literally just myself and Jeffrey Yaskin. But I really hope that we can use this to continually raise the bar, to have better, more welcoming, and a more collaborative environment for developing standards. And I think with that, I have wrapped up. Thank you for coming. I think I have several minutes left if there are any questions or comments on anything. Thanks. And that went faster than I thought it would. So I was talking really fast.
All right, we have a comment from the audience.
We have Alex raising his hand fiercely.
Thanks for this, Chris. This is more of a comment, not a question. I'm kidding. You mentioned specifications and how they're different from standards. Can you maybe try to enunciate how you think about specifications, standards, and explainers relative to each other?
Yes.
Thanks.
So I tend to think of an explainer as the starting mode for a specification. It leads to a specification, but it's a lot more readable. So when you get started, don't write a spec. Like, don't start by trying to write the detailed code to do what you think you want to do. Write a short document that says, here's the problem we're trying to solve, and here's the approach that we think we're going to take to solve it. That develops over time. You should keep that up to date, by the way. Like, don't just drop the explainer at some point. Usually it's a good idea to keep going with it and have that be a companion to the spec. At some point, you do have to start writing the detailed specification, all the steps, all the IDL, that kind of stuff in there. The difference between a spec and a standard is basically time, buy-in, and interop. Like, it's a progression. You have a specification. It eventually gets to become a standard by the fact that it is interoperably implemented. It's not like you changed something totally different about it. But explainers, absolutely the best tool to start with. And it is a good way to explain yourself to people who don't want to read the entire spec front to back, backwards, etc.
We have another question from the audience.
So I think we think about specifications as once they're interoperable, but we also have various stages within the standards track, various stages of working drafts and recommendations. What do you think is the best way for us to think about a standard, maybe irrespective of what place it is on the track, whether it's a candidate recommendation or technical recommendation, etc.
What do you mean by how you should think of it on that track?
Yeah, so it could be, for example, like all browsers have implemented something, but the spec is not advanced to sort of the final stage. Maybe the more practical question is like, why should we go after, making it, continuing to iterate on that standard so that it becomes a final recommendation when maybe implementers have already agreed on interoperability.
Okay, so I think a really good capture of the value there is history. So it is a really great thing, actually, if browser vendors do all agree and engines do interoperate and the spec just doesn't capture that, because that's a fixable problem. Go in and write a new spec that actually captures what happens and what is interoperable, what steps you go through to get there. Like, this is the foundation of the WhatWG, was that exact thing, like write what works in practice. There are so many different paths for how you get from the inception of an idea to a standard, and it's hard to capture all of them in the same diagram. I thought about this once and I started sketching and it was too complex to fit on a slide. There are a lot of communities that are very tight. There is fairly symmetric investment across multiple vendors. Like CSS features tend to be this way. ECMAScript definitely is this way. WebAssembly even, where you can move things forward and get multiple implementations of things because people all agree roughly on how much investment and what speed this should happen at. They care a lot about interop. They have very explicit stages to walk through, and that path is very clear. There are also features like a lot of the Fugu features, for example, where there aren't as many engines who are interested in them right now. So we can write a great spec, but the path to get all the way to web standard that is interoperably implemented is not as clear today. So it's harder to map that end out in the same way. I'm not sure if that answers your question or not. Okay. Yeah.
Hi. You mentioned IP obligations for spec becoming standards, and you also mentioned trying to make spec and standards work more inclusive. Those things can conflict. I'm thinking of the WhatWG has a real name policy for contributors who are individuals rather than working on some established web organization. And well, you think that that is simple enough, but there's a list of falsehood programmers believe about names. That is having in your real name listed there in that list is particularly not inclusive for trans people. I've seen a couple of cases where some contributor wanted to do something in the WhatWG and they have been burned out by that situation. Or in one case, I think someone who I suspect might be trans was forced to reveal their name. And so, yeah, what do you think about that? How can those things be made better?
Yeah, so this is a great question. It is very, obviously it's a very sensitive question. I think that it is very important to be understanding and figure out good solutions in that case. There's other balances to that. Like the main driver of that real name policy is we needed to have an actual IPR policy for the WhatWG. This is not done, by the way. I'm also our Google's steering group representative. We still have an open issue on how to improve this. And I think that if people are still finding this a sticking point, we should have a more active conversation about how to improve it. I think we've gotten to a reasonably good place, but I'm not sure if we can't make it better. I think we're a little more flexible than you might think in how open you have to be about your real name, but we can talk about that. W3C, by the way, very different. They're not as, I don't know how to put it. They're not as okay with more anonymous participation. They're a little more worried about the patent policy applying than what WG is, which makes it a little more challenging.
All right, we should wrap up.
Thank you very much.